Algebra 1. Today we're going to do lessons 41 and 42. 42. Okay, try to skip that in. If you know the answer to this question, what book is 42? The answer to life, the universe, and everything. If you think you know it, I got it in the room. But I want to try to combine lessons 41 and 42 today, 2 days of lessons. So we're starting on page 165. Let's talk about addition of like terms and rational expressions. Sometimes when we do math, it's difficult to determine the terms in a rational expression are like terms. For example, it can be really difficult to see that two of the terms are like terms and may be added. If each of the terms is written in the same form, however, it is easy to identify like terms. Let us write each of the three terms with all expressions, all exponents, I meant to say, positive. If I do that, which we have previously learned, I get this. Now, it's quite easy to see what I can combine, excuse me, just based on that. So the first part of lesson 41 is exactly that. That's what we're going to do. Let's take this example. Let's make it so all exponents are positive. So in essence, we're going to do a little bit of rearranging here. B to the fourth over a to the third plus 2b to the fourth over a to the third. And you can see how we got that because this one's already positive. That one's all good. I don't have to change anything. When I move b to the negative third up and I add 1 to it, I get b to the fourth. And I move this down, it becomes positive, and I get a to the third. Then you should be able to realize that 2b4 plus b4 equals 3b4, and you already have a common denominator. And we'll worry about in the future what to do if we end up with a common if we end up having to make a common denominator, but not today. Now your book is going to be really handy as you're doing these. It'll tell you how it wants you to do these problems, and how it tells you how to do it is going to be of the best benefit to you. So in this case, again, let's write so all exponents are positive. When you do that, you get 7cb squared a to the third minus 5cb squared over a to the third plus 3b squared over a to the third c. As you can see, you got two like terms, the first two. 2cb squared, 7 minus 5 is 2, over a to the third, plus 3b squared over a to the third c. And pretty easily you can see how you can do that. Now, two-step problems is our next section of lesson 41. And to do two-step problems, we get a problem that says this. If x plus 3 equals 7, what is the value of x minus 8? Okay, so we want to know what x minus 8 is, but to do that, we have to first find out what x plus 3 equals 7 is. Subtract 3 on both sides, we find out that x equals 4. And since x equals 4, then we'll plug 4 in here. 4 minus 8 equals negative 4. Pretty straightforward. If x minus 5 equals 7, what is x plus 4? Again, now we're going to add 5 on both sides to find out that x equals 12. Now that I know that x equals 12, let's put it in there. 12 plus 4 equals 16. That is lesson 41. Take a break, pause. Tomorrow, lesson 42. All right, so Here we go, lesson 42, and at just about the 5-minute mark. That's kind of what I was hoping for. Solving multivariable equations. What are you going to do when you get an equation that looks like this? That's a lot of variables. We want to, and so how do you solve this problem? Well, it depends on what you're being asked. For example, if you're being asked to solve for y, you want to get y by itself. So I'm going to add x and subtract z on both sides. That's going to give me 6y equals 4 plus x minus z. Now I got to get rid of that 6. So I'm going to divide 6 on both sides. That means 6 is going to go to everything. So y equals 2/3, because I can reduce 4 6, plus x over 6 minus z over 6. Okay, not too hard. This is a 2, by the way. It looks kind of sloppy. Okay, so solve for y again. We want to solve for y. 4x minus 2y plus 2 equals y minus 4. So same type of thing, but this time a little harder. So I want to add 2y on both sides. That gives me 4x plus 2 equals 3y minus 4. Add 4 on both sides. Okay, that's going to be 4x plus 6 equals 3y. Divide by 3 on both sides. That equals 4x divided by 3 plus 6/3, which is 2, equals y. Because I would have 6 over 3 right here, I could know that that's 2. So I can easily solve that problem. Let's solve for x on this one. 5y plus x minus 2y minus 4 plus 3x equals 0. All right. I want to solve for x. So I want to get everything that I can away. So when I do that, first off, I can identify that these two are like terms. That's going to give me 4x. But other than that, what to solve for x, and I need to also get rid of these like terms. That's 3y, that's 4x. So now I end up with 3y plus 4x minus 4 equals 0. Now, to get rid of this, I'm going to subtract 3y on both sides, and I'm going to add 4 on both sides. So I end up with 4x equals negative 3y plus 4. Then I'm going to divide by 4 on both sides to get x equals negative 3/4 y plus 1, because 4 divided by 4 is 1. These aren't too hard, because all we're doing is just solving for certain equations. Let's try another one. Let's solve for y. 4y plus 6x minus 4 equals 2. Okay, again, we're solving for y. So let's subtract 6x and add 4 on both sides. When I do that, I get 4y equals 6 minus 6x. Now I'm going to divide by 4 on both sides to get y equals 3 over 2, because reduce 6/4, I get 3 over 2, minus 3 over 2 x, because 6/4 becomes 3 over 2. Now one more. Solve for p. 4p plus 2a minus 5 equals 6a plus p. To do that, I want to subtract p on both sides. Okay, that gives me 3p plus 2a minus 5 equals 6a. Subtract 2a and add 5 on both sides. That gives me 3p equals 4a plus 5. Divide by 3 on both sides. That gives me p equals 4/3 a plus 5/3. So, in short, if an equation contains more than one variable and we are asked to solve the equation for one of those variables, our task is the same as what we've been doing. Our task is to isolate that variable that we are told to solve for. So we have to rearrange the equation so that the designated variable is the sole member of one side of the equation. It's isolating the variable. Nothing changes from what we've done before. As you can see, we just worked out 4 or 5 different examples, and you can see that this is the exact same stuff you've been handling for a while. So there you go. That's lesson 42.